This is PreCalc 11, Chapter 5.4. We're going to look at solving systems of equations graphically. And this is the same as any of the equations that we've dealt with. We just set y1 equal to y2 and we look for the intersection. However, we can solve it as y1 minus y2 equals 0. In this case, we would look for the x-intercepts rather than the intersects. And it's also easier to graph the combined function. And you can also use the discriminant or the quadratic formula if necessary. And note that we can use this type of solve for any type of equation. But let's do the intersection first, just so that you know how it works. Here's an example. 4x plus y equals 700, and we have y equals 1/3 x squared plus 2x plus 3. First of all, we need to change this into an explicit y function. So y equals negative 4x plus 700. We move the 4x over to the other side, it becomes negative. Okay, I'm going to use the Casio this time. So all we do is we enter the two functions, negative 4x plus 700, and instead of doing 1/3 times, I'm just going to do x squared divided by 3 plus 2x plus 3, and we draw. And we get something like that. So the problem is we can't see the linear function. We must adjust the window to see this. So as suggested, we're going to be setting the window to this, negative 70 to 70, and we need to adjust the y. We'll leave the negative 3.1, we'll change this to 1000. The reason why I'm setting it to 1000 is we know the y-intercept is 700. Okay, and now we get something like this. And to solve this, all we have to do is go gsolve, and we're looking for intersect. And that's the abbreviation for intersect on this computer, so we press F5. We get our first one at negative 55 and 922. But all we're looking for is the x value. So they intersect at negative 55.6 roughly and 922.4 for the y coordinate. And to get our other answer on the Casio, we just press right, and we get approximately 37.6, 549.6. Okay, let's look at this on the TI. So we have negative 4x plus 700, and we have x squared divided by 3 plus 2x plus 3. And we'll just adjust the window, negative 70 to 70, and we'll plug in 1000. Set the scale to 100, set this scale to 10, and graph. Okay, to solve this, we press second calc, and we're looking for the intersect. So that's 5. We select the first curve, we just press enter, second curve, press enter, and then we just want to scroll over a bit to get the left one. I'm just holding it down. And it calculates the same one. To calculate the second one, we press second calc, 5, enter, enter, and then we need to scroll. And remember, we need to be on the same slope as the intersection point. For this one, we need it to be on this slope to get that intersection point. And that's good enough. And we get our second answer. It matches this. Okay, let's look at the same problem, but we'll use y1 minus y2. Let's call this one y1, and we'll call this one y2. So we have 1/3 x squared plus 2x plus 3 minus, and put this in brackets, negative 4x plus 700 equals 0. And the note here is use brackets to avoid sign errors. And I'm going to go window, and I'm going to go to standard. Just so that we're starting off with the same foot. And exit. And delete. And delete. And I'm just going to enter the formula. X squared divided by 3 plus 2x plus 3 minus bracket negative 4x plus 700 and close bracket. And draw. And there's nothing on the screen. So we go to window, negative 50 to 50. And again, I'm picking 700 because 700 is our y-intercept. And draw. And we get something that looks like this. And I just press G-solve, which is F5. And I'm looking for a root. Exit. I don't want to do that because this root isn't in the window. We need to adjust this to negative 70. And draw. And now we can press G-solve. And we're looking for the root, so we press F1. And it automatically picks the first one. We scroll over. And we get the second root. This time we don't get the y value. The y value is just 0. But we're mostly concerned of solving for x in these problems. Okay, let's look at the TI. Clear that, clear that. X squared divided by 3 plus 2x plus 3 minus bracket. Use this negative sign or you might get an error. Negative 4x plus 700, close bracket. And we'll just go ahead and set the window negative 70 to 50. And we had negative 700 to 700. Negative 700 to 700. And our scale is going to be 100. And draw. Now, if you don't set the range big enough, you will have very vertical lines. And that makes it hard to set a left bound and a right bound. So make sure that you have a sufficiently large range to have a slant on your curve. We don't want it to be too vertical. I'm going to go second calc, and we're looking for zeros this time. And we set our left bound. And we set our right bound. And the guess. And we get the same answer. Let's find the second one. Second calc, 0. This time we need to be over to the right side. And that's good. And that's good enough. And we get our second answer. And it matches here. Okay, here's another question. Find the intersection. But we're going to use the second method. So we're going to call this one y1. We're going to call this one y2. And the reason why I'm doing that is because I don't want to start off with a negative sign. So y1 minus y2 equals x squared minus 9x minus 50 minus, and in brackets, minus x squared over 2 plus 18x plus 40 equals 0. So x squared minus negative x squared over 2, that's 3x squared over 2, minus 9 minus 18, that's minus 27x, minus 50 minus 40, that's minus 90, and we can enter that on a calculator. This time I'm just going to use the Casio. You can figure out what to do on the TI. Okay, we have 3x squared divided by 2 minus 27x minus 90. Graph. We're going to adjust the window to this one. Negative 30, 30, and negative 100 to 100. And draw. Okay, that gives us a slightly better graph. And again, we're solving for the root. So we get negative 2.87 approximately, and press right, and we get 20.87 roughly. So the trickiest thing about using your calculator is setting a decent window so you can see your answer. And generally you want to make it bigger. So you want to make the x min and max bigger and the y min and max bigger until you see enough of your curve. And that completes this lesson.